Figure 19.4 ListTest.java. In this example, we're going to focus exclusively on list data structures, and we're going to take a look at the new class called LinkList and also at the concept called a list iterator, which is an enhanced iterator that is specific for interacting with lists, and it does add some interesting capabilities. So we're going to take a look at our list test class, and similar to what we did in the last program, we've created a couple of private static final string arrays, one called colors and one called colors2. And in each case, we've initialized the lists with strings, black, yellow, green, blue, violet, and silver in the first case, gold, white, brown, blue, gray, and silver in the second case. Now, as we did in the last program, if you take a look at main, you'll see that all we do is create a new object of our class, which calls its constructor, and after the constructor finishes executing, this program will terminate. So let's take a look at our constructor in the example, which is going to lead us through everything we intend to do here. Now at line 17 and 18, we're creating new linked list objects, and again we chose to create linked lists of strings. And for a linked list, you don't specify the size of the list because it creates each new node in the list as we say to add new items or insert new items into the list. But notice one thing that we are doing similar to the last program, which is we're taking this linked list object that's being created and assigning it to a variable of type list of string, not of type linked list of string. And that gives us again the flexibility of potentially changing the list implementation that we use at a later time. So we create two different lists, list 1 and list 2 in this case. Both of them are linked list objects that store strings. Now at line 21, we've chosen to use a loop to iterate through the colors array, and one string color at a time we're going to take that color and add it to the end of whatever list 1 is referring to. And at line 25 we do the same thing, adding all of the elements from the colors2 array into the list2 object. Then at line 28 we invoke the list1 object's addAll method and give it list2 as an argument. And this is actually going to concatenate the lists and physically remove elements from list2 as we go. And that's one of the reasons that we're setting list2's reference to null after that operation, because we don't need that list anymore. So we literally take all of the elements in list 2 and add them to list 1, and then we've said to go ahead and print that list 1 out so we can show you that all of the strings from the 2 arrays are now in that one list object. So let's stop there and take a look at our output for a moment so we can show you that part. Okay. And you can see here that the list now contains all of the different strings that were in both of the arrays of strings originally. Now, the next thing we do is we invoke our own method, convert to uppercase strings, and we give it list1 as an argument. Now, if you scroll down to convert to uppercase strings, you'll notice that this method receives a list interface reference for a list of strings as its argument. And in the body of this method, we've chosen to use a list iterator rather than just an iterator. And the reason for that is a list iterator actually enables you not only to walk along a list, it also allows you to modify the elements at each location in the list. So we get that list iterator back and we assign it to our variable iterator, which is a list iterator of strings. And then we use a while loop to iterate through our collection, first checking to see if there is a next element to look at. If there is, we then go to line 59 and we grab the next element by calling the iterator's next method, just as we did in the last application. We know that we're looking at a list of strings, so the result of this operation is going to be a string that represents one of the color strings in the array, or in the list, excuse me. And then we use one of the key new features that we're demonstrating here. The iterator has a set method that is actually enabling us to change the element at the current location that the iterator is referring to in the list. Color.toUpperCase is going to produce a new string which has the same contents as the color string but in all uppercase letters. The original string is then going to be replaced with this new string at the current location that the iterator is pointing to. And if you take a look back in the constructor here, after we call convert to uppercase strings, we call our print list method once again, and here is the part of the output that was produced, and you can see position by position that we really did replace every single one of the strings with its corresponding uppercase version. By the way, we forgot to look at the print list method, so let's just take a look at that for a moment. You'll notice that print list receives a list of strings as its argument, and in the body this time we chose to use the enhanced for loop to iterate over the list. And by the way, what's really going on underneath the hood here is that the enhanced for loop is obtaining an iterator from the list. One element at a time, it's using the iterator to the iterator's next method to obtain the value that is being placed into the control variable, and it's also using the hasNext method to determine whether or not there are more items to iterate through. So all of that's going on behind the scenes of the enhanced for loop when you apply it to a collections framework class. Okay, back up in our constructor, the last couple things we're going to do are to remove some elements from one of the lists and also to print a list in reverse order. So first thing we say is at line 35 that we're deleting the elements item numbers 4 through 6 in the list. Now remember, you can iterate through lists using index numbers if you want to. So what we're saying is we want to actually delete from the original list the elements at position numbers 4, 5, and 6, which would be the 5th, 6th, and 7th elements in the underlying collection. And when we call our remove items method, notice that we give it the list we're removing elements from, the starting index where we want to begin removing elements, and the one past the end index. In other words, we want to remove up to but not including the element at position number 7 in the underlying list. So let's take a look at our remove list method, or remove items method, excuse me. At line 65, we define remove items to receive a list of strings as its first parameter, a starting index, and an ending index. And take a look at this extremely powerful operation that we're performing here. We're asking the list to give us a sublist of itself. Now, the sublist method is interesting because what it actually does is it creates a view into the existing lists. It doesn't actually create a separate list in memory. It creates a view into the original list that starts with whatever item you indicate and ends with the item before the ending index number. So we're going to go from position 4 up to but not including position 7, and thus we will have a sublist view into the main list that starts at index number 4 and goes through index number 6. Now when you invoke the clear method on a list, it deletes the elements in that list. We're not invoking the clear method on the entire list, we're invoking it on the sublist that's produced by this expression. So what this method call for clear actually does is it removes the elements in that sublist, which are the elements that were originally at index numbers 4, 5, and 6 in the underlying list object. So after we perform this operation and we go back up to our constructor, we print out the list contents, and if I show you my output after we've deleted element numbers 4 through 6, you can see that the list is indeed shorter, and in particular, let's go back to the original list, items 0, 1, 2, 3, 4. Violet was the first item that we were going to remove, and you can see that through blue they are the same. So violet, silver, and gold were being removed, and then white, brown, blue, gray, and silver are the remainder of the list that's left over. So you can see that indeed we were able to delete the sublist from the underlying full list object. And then finally we have our method print reversed list that we're going to take a look at. And in this case, once again, we receive a list interface reference as its argument. And notice that when we obtain the list iterator, in this case at line 73, that we give an argument to the list iterator method saying list.size, which is the total number of elements in the list. What this does is it gives us an iterator pointing to just after the last item in the list. We assign that iterator to a list iterator of strings, and then we're going to print the list in reverse. And just like we did with has next and next, we have a has previous and previous method. So if the iterator has previous items in the list to look through, then this condition will return true, and then we'll say move to the previous item and take that item and display it as a string. And finally, if you look at the last piece of the output, you can see that the highlighted output is in the reverse order of the prior output in the output window.
Looking to advance your career by acquiring new skills? Tired of expensive off-site training programs? Wish you could learn from the best instructors in the industry? Look no further than Live Lessons. Self-paced, personal video instruction by the world's leading technology publishers. Each live lesson comes with a DVD featuring 3 to 4 hours of instructor-led classroom training, sample program code that allows you to work along with your personal instructor, and an example-rich study guide. Live lessons allow you to watch the entire course from start to finish, or navigate directly to any of the individual lessons. You'll literally watch over the shoulder of your instructor as he shows you how to build state-of-the-art applications. Live Lessons, the power of the world's leading technology experts at your fingertips. To learn more, visit mylivelessons.com today.